Our next lesson is on the properties of logarithms and on the change of base formula. Your essential question is how do you use properties of logs and how do you change the base of a logarithm? So I'm going to start by just introducing you to the properties. They're quite simple to work with once you memorize them. And the reason that we have these, for the most part, you won't really see until you get to calculus, where a lot of times in calculus, in order to calculate rates of change, if you're dealing with logarithms, you're usually going to want to transform the way the logarithm looks so that way you can work with it. And there will be one of these properties actually will be very useful for us. The rest of them is just kind of an exercise in using them. All right, so let's just get down to the properties. So the first one is the product property. And these follow really closely with the properties of exponential functions. So when you're working with exponents, you'll notice that these follow really closely. So when we were working with exponents, if I gave you x to the a times x to the b, because we had like bases, we were able to then just say, oh, this is x to the a plus b. Okay, well, the product property of logs works really similarly. So if I give you log base b of some product, like u times v, then I can basically break this up into two logarithms so that I have log base b of u, okay, that's the first factor there, plus log base b of v. Notice that addition is coming in here again. I had a product. Okay, a log of a product is really the same thing as the sum of two logs. All right, so the next one we'll do is the quotient property. And so just as a reminder, when we dealt with quotients with exponents, for example, if I gave you x to the a divided by x to the b power, that was really the same as x to the a minus b. So the same thing is going to happen with logarithms. If you have the logarithm of a quotient, so log base b of u over v, or u divided by v, now what we can do is we can break this up into two logs and subtract them. So this is going to be log base b of u minus log base b of v. Okay, so these two are pretty abstract to you right now. You just need to memorize them. You're not really going to get to see like a huge use for them until you get to calculus, or even pre-calculus. We'll use a little bit of it. The next property, though, is huge. And that is the power property. Okay, so back when I first introduced logarithms to you, we had an issue where the town of Ferndale was being overrun with zombies, and everybody was turning into a zombie, and we realized that that was going to be some kind of problem, like 3 to the x power would equal the population. And I said, okay, right now you guys you don't know how to solve this yet, but I'm going to show you a way to solve this. Okay, so this is where this power property comes in. So I'm going to introduce the power property, and then we'll finally work this problem out. So the power property says that if I have log base b of u raised to some power, let's say n, then what I can do is I can bring the power down. Okay, I can bring that power down and multiply it by the log. Well, that sure would work nicely here. Okay, so one thing that I can do is I can take this equation, and I'm allowed to do the exact same thing to both sides of an equation. Okay, so I'm allowed to say to myself, let me take the log of both sides. So my new equation here will become the log of 3 to the x power equals the log of 1,362. And I could use ln too. Okay, the bases will just be different, but it would give me the exact same answer in my calculator. Okay, now using this power property, allows me to bring my x down. And now I can solve for x. See how x is being multiplied by log of 3? Well, to undo multiplication of log of 3, I can go ahead and divide both sides by log of 3. So I'll get the fact that x equals whatever this is divided. Okay, so let's see. Let me go onto my calculator here and do that. Okay, let's whatever this guy's doing. Sorry about that. Okay, so let me just go ahead and get myself a clear screen here. Oh, let's clear everything. All right, so I'm going to do log of 1,362 divided by log of 3. Okay, so I just use my log button. And I'll divide that by log of 3. And we find out we have, I believe this was happening per hour. So we find out that we have about 6.5 hours left until everybody in Ferndale's a zombie. And I can do an approximation. How about we do approximately 6.6 hours until everybody in Ferndale is a zombie. Okay, so this was the zombie problem. I'm just going to label that. That way if you go back and you're looking at this, you're like, what the heck? And what we use to help us solve this is the power property. So this is one that's going to be huge for you guys right now. And then for those of you that go into calculus, these other two are going to really help you be able to do some of the work you need to do. All right, so let's practice some of these things. Let's see, I can get rid of this. All right, so example 1. We're going to use log properties. To evaluate. Okay, so we're going to take log, this is A. Log base 2 of 4 times 16. Okay, well, using our product property, we can write this as 2 separate logs. Because what's happening right now is it'd be really nice if I could just say, oh, well, this is really just 64. Let me just punch log of 64 into my calculator. Problem is my base here is 2. So that's not going to work out because we don't have a base 2 log in our calculator. We have a base 10. We have a base E. That's all we got. Okay, so maybe I can rewrite this so that I get some powers of 2. All right, so let's see what I can do. So how about I start with breaking this up. So I'll have log base 2 of 4 plus log base 2 of 16. Okay, and then I'll write both of these with, since the base is 2, remember, if I can get this to be some exponential function with a base of 2, then they'll basically undo each other and I'll just be left with whatever the power is. Okay, what the heck am I talking about? Well, let's keep working. So this is going to be log base 2. 4 becomes 2 squared plus another log base 2, and 16 becomes 2 to the 4th power. Okay, so from your last lesson, hopefully you've picked up on if you have an exponential being put into a logarithm, right? So you got that compound function or that composite function, not compound function, sorry. You've got a composite function. You're plugging an exponential into a logarithm. They have the exact same bases. Those undo each other. You're left with the input. Okay, so this is going to be left with 2 plus, same thing here, right? Same bases, my log and my exponential, same base, just left with the input. And so that's going to equal 6. Okay, did I really, on that one, I'm not sure I really needed
to use my log property, but it was fun because I could have done the same thing, right? 64, it would have been 2 to the 6th power. But it's a good time for us to explore using our properties. Okay, so let's try one more of those. How about if I do log base 2 of 4 cubed? Okay, so what I can do here now, this is that power property, that power rule, that allows me to bring that power down. Okay? One way of handling it. Now, I love this property, so you're always going to see me using that if I can. Okay? There are, again, multiple ways of handling these problems, but I'm going to go ahead and bring that 3 down. I'll have log base 2. Now, instead of using 4, I'm going to get like bases. So I'll use 2 squared, right? So now my log and my exponential have the exact same base, which means that they undo each other. I'm left with the input times my coefficient there, which was 3 times 2. So I'm getting 6. Okay, let's do some more examples. All right, so let's do C. Now let's do ln, which is really log base e, right? Let's do 1 over e cubed. Okay, well, right now I don't have, I could do this several ways, but again, I'm going to use our properties right now, okay? But, you know, I could work with some negative exponents here. I could do a lot of things, okay? But I'm going to go ahead and say, I notice that I'm taking the logarithm of a quotient. That's a quotient. So let me go ahead and rewrite this then as the difference of those two pieces of the quotient, okay? So a difference of 2 logarithms. So ln of the numerator would be 1 minus ln of the denominator would be e cubed, okay? Now I can do a couple of things here, and it depends on how you want to do it, but, well, first of all, ln of 1, if you think back to the graph of a logarithm, there are a few points that you should, or there's one point that you should definitely remember. So I don't have an a here, right? And remember, your exponential looked like this. And if I didn't have an a, I went through the point 0, 1. Well, the logarithm function is the inverse. So that tells me that 1, 0 is on that graph, and it looks something like this. So if I plug in ln, if I plug 1 into ln, I get 0 out. That's my output. Now from here, I could do a couple of things. But let me remind you that ln is really just log base e of e cubed. So notice I got like bases. I got an exponential being plugged into my logarithm. I could use my power rule if I wanted to. Okay, bring that 3 down. Or I could just say to myself, well, these are inverses, so the input is what I'm left with. So the log base e and the e undo each other. And you don't actually have to rewrite it, log base e. You can just look at it as ln of ln. But I did this to kind of help you out. So if you're struggling at all on that, then maybe sometimes you want to rewrite it with a base e. All right, so this is really just going to give me, well, 0 minus my input, which was 3, or in other words, negative 3. All right, so now we're going to do some expansions. Let's see here. So in your book, they'll just give you some general instructions. Expand the expression, condense the expression. So we're going to expand the expression. So we'll do log of the product 4x to the 5th. Okay, so I'm going to start off, I'm going to expand this. So I'm going to get it as condensed as possible. I'm going to make it as big as possible, as long as possible. Okay, so basically I'm going to use every single property that I can. So I notice that this is a product.
So that means that I can write it as a sum of the logs. So this will be log of 4. And if you don't remember, if there's no base, that means it's base 10, okay? Plus log of x to the 5th. Now, you may think, okay, I'm done, but you're not. Remember, you still have that power property, okay? Or that, is that what we called it? The power property, yeah. Different textbooks call it different things. So, okay, so we're going to use the power property now because I still have this power and we're going to bring it down. Okay, so we'll now just have log of 4 plus 5 times log of x. Okay, that is there's nothing more I can do. Okay, I've used all my properties, so this will be my answer. All right, let's do another one. Log base 6 of 10 divided by 3. Okay, so you can notice this is a quotient. Okay, and there's a reason we would expand this. And it might be so that we can change our base later on and not have to work with like a compound fraction. Okay, so notice this is a quotient, so that means that I can rewrite it as the difference between two logs. So I'm going to have log base 6 of the numerator and subtract from that log base 6 of the denominator. Okay, and we're going to go in and change the base formula here in a minute, so you'd be able to actually evaluate this at some point. All right, let's do one more of those types. Log of the square root of x. Well, remember, the square root of x is really like x to the 1/2 power. So how can I deal with this using my properties? Well, I notice I've got a power, so I can bring that power down. Okay, so I'm going to have, oops, not that. We're going to have 1/2 log of x. That's as expanded as it's going to get. Our next example, we'll just condense now. So we expanded using those properties. Now we're going to condense. So example 3, condense the expression. Okay, so let's say I give you log base 5 of 8 minus log base 5 of 12. Well, notice that this is a difference of two logs. So, and both logs have the same base, right? So I can condense it by using one of my properties. Now, which property has subtraction in it? The quotient property, right? So I'm going to take it and I'm going to make it back into this, where I've got one log with a base of some quotient. And the quotient comes from what are the inputs of these logs? 8 and 12. Okay, so we're basically going to say this is log base 5 of 8 over 12. You can write it like that. I like to put parentheses around my inputs of my logarithms. That way I know that those are my inputs. Okay, we'll do one more of these. So how about we do 3 of ln, or 3 times ln of x plus 5 times ln of y. Well, notice both of these ln's are being multiplied by something. So those could actually be brought up to be powers. So that's where I would start. Okay, so what I'm going to do first is I'm going to say, well, this is really ln of x cubed plus ln of y to the 5th. Now I've got a sum of two logarithms, same bases, so now I can use that product property to make them into one ln. So this is just going to be ln of x cubed times y to the 5th. And again, you can put those parentheses around your input if you'd like. Okay, I'm going to show you guys one more thing, and that is the change of base formula. This is so that you can always use your calculator when you're allowed on logarithms, so that you can actually evaluate them and get an actual answer and approximation. All right, so here's the change of base formula. And this, again, is just something that you memorize or make sure you have on a note card. I'll put capital B. Change of base formula. Okay, I can take any logarithm and I can rewrite it with a different base. And I can choose whatever base I want. But again, the only reason that you'd really use the change of base formula is so you can put the stuff in your calculator. So you're either talking about log base 10 or log base E, which is ln. Okay, so use to convert logs to base 10 or E. Okay, so that's when you would use this. If you're just doing this for fun, then I don't know. I don't know what to say. I'm excited for you, but probably want a different hobby. All right, we got log base A of U. I can change this to any base that I want by rewriting this. Okay, I basically will just take the input of it, do a log base B, whatever base I want, of the input, over the same base of the base. That's it. So I'll just do a few examples with that, and then we will call this video done, and we'll get to work on these a lot in class. All right, so example 1. Oops, sorry, we're on example 4. It would be example 1 with this, but example 4. We're going to use the change of base to evaluate. If I want to evaluate, that means I want to end up with an answer, okay? And how about we round to the thousandths? Okay, we'll always round to the third decimal place. All right, so the first one is going to be log base 5 of 7. So again, there's no log base 5 on my calculator. There's a log base 10. There's a log base E, or ln. Okay, so I can decide which one I want to do. It's totally up to you. You're going to get the exact same answer. Okay, so log base 5 of 7. Well, how about we start with, we'll change that to a log base 10. So I'm going to do log base 10, because that's the base that I want, of the input, right? That U, that's the input, so that goes on the top. Over, same exact base, log base 10, of the base. Okay, that goes on the bottom. So here it's 5. All right, so then I just take out my calculator. I'll do, and you don't need to type in base 10. The calculator knows that. That's what log is defined as your calculator. So log of 7 divided by log of 5. And I'm going to get an approximation. So you get approximately 1.209. Pretty easy, right? Change of base is probably one of the easier things once you have it memorized. Okay, let's do another one. So I've got log base 2 of 125 that I need to evaluate. So I can, and it's totally up to you. How about we do ln this time? Okay, so that's log base E, or I can do ln of 125 over ln of 2. This is where it comes in really handy in calculus, because we work with ln, derivatives of ln a lot. And if I'm given a logarithm on any other base, I can change it to an ln function, which works really nice for us. Okay, so going to my ln of 125 divided by ln of 2. And I'm getting approximately 6.966. Oops, not 9. And you would have gotten the exact same thing had you done it with log base 10. Okay, we'll do one more. So how about I do a log base 2 of 4 over 15. So you have a couple ways to deal with this. One would be to use our new properties so that you don't have to worry about maybe dealing with a fraction. Okay, you could turn this into a difference and then take the difference between the two logs. The other thing that we could do is we could actually
use fractions here. Why don't I do it both ways just for fun? So why don't we start by breaking this up into two logarithms. So this is going to be log base 2 of the numerator minus log base 2 of the denominator. Okay, so let's see what these give me. So, I can't do that yet. Okay, so now what I need to do is I need to do the change of base on each of these. Okay, so I'm going to do log, and I'll do base 10. I don't need to write base 10, okay? I'm not going to write it. Of the input over the log of the base. Okay, and from there I'm going to minus log of the input over log of the base. Okay, so this is one way of doing it. So let's see, we got log of 4 divided by log of 2. We'll get an answer for that. And then from that, I'm going to subtract log of 15 divided by log of 2. And I get approximately negative 1.907. Okay, so that's one way of doing it. The other way would have been to go directly to log base. So this is one way. Let's do it one more way, just for practice with everything, okay? So the other way would be to say, okay, let me do log of my input, which is 4/15, divided by log of my base. Now let's see if I get the same answer. So log of, I'm going to do 4, divided by 15. I probably have too many parentheses there, but that's okay. And then I'm going to divide by log of 2. Do I get the same answer? I do. Look at that. It's approximately the same thing. So it's up to you how you want to work with them.